Welcome back to Tailored Motor TV episode 4. I refined the vision of Tailored Motor, and one word is making electric motors simple. It took some time for me to make the next video. I'm very sorry if you had to wait. It is because I programmed the web interface. And programming a web interface for me is not a day-to-day job. It took me some time to figure out the jQuery and the HTML5 canvas and all the JavaScript needed to make it interactive. I made that interface for the reason that I think we want to sell motors online, and we want to make it in a way that it is self-explaining, because we want to be focused on the customer. So we want to exactly know what the customer wants, and in the meantime we want the customer to save time, to quickly be able to transmit what he exactly needs and get a feedback. Is it possible, and what is the influence of what he is asking for in regard to what can be done? Because that's something I experienced in many times in business-to-business sales. When you contact a company that is specialized on whatever it is, you as a customer usually know much less than the salesman, and then you go back and forth and you ask for maybe something that for you is very simple, and then the salesman tells you that's something that's very difficult to make, and we can't make it because he maybe understood you wrong. And so I think we need to improve that communication, and that's why I made that interface. And that's, I think, a good impression of how exactly I want to create it, and how I want to have that communication going on between our customers and our factory behind it. In my next video I will then go into the mathematical model we need to calculate all the data we need for manufacturing. So we get that data out of that interface that you will see now, and we then run it through a mathematical simulation to get the diameters, the length, the size, whatever, the windings of the coil, that we can then feed into our production machine to produce your customized motor. So let's start the show. So hello, this is the configurator I created in the past days because I wanted to look at the Tailored Motor project from a pure customer view. I had several contacts to motor manufacturers thanks to my day job, and the sales process was quite annoying, and so that's how I would sell electric motors. And instead of trying to explain you the interface, I started programming it. It's a pure dummy. There's a lot of functionality not yet working, but I think it shows you the idea. In 7 easy steps we can configure a motor. I mean, a motor is still something a bit difficult, it's still something technical, so I can't make it in just one click like an Amazon buying, but I think in 7 easy steps every technically interested person can go through these steps and learn something about motors on one hand, and configure a motor as it should be for his or her application. We start with the operation mode. That's very important, whether your motor is just running continuously at a fixed speed, whether it is an intermittent operation starting and stopping with some pauses in between that allow the motor to cool down, or if you have a highly dynamic operation like in a pick and place robot where you need high torque nearly all the time, which then causes very high thermal stress on the motor. And because you have start and stop all the time, you're often outside of the optimum RPM range of a motor, so that's the worst case for a motor. But I think with these three cases we covered all kinds of uses for electric motors. It doesn't matter where that motor will be used, it will fit in one of these three use cases. Let's assume we have intermittent operations, so I can select it. I see it's selected. And then of course we have to cool it. The better we cool it, the smaller we can make the motor. Most motors, electric motors, die a thermal death, so if we get rid of the heat, it's better. But we don't always have the space, we don't always are willing to push air through. So if we have something that needs to be extremely quiet without airflows or so, we can go for passive cooling. The ambient air temperature is of course an important factor to know for this. If we want to have a higher power density, we can go to fins on the motor and fan pushing air through. And if we want to go to very, very high power density, we can go to water cooling. That is useful if you have a very complicated machine with very limited space inside, but you are willing to add a water cooling system to cool your motors. Technically it's always the same motor, it's just the housing that changes, and the housing then is the cooling. So we think that with our motor toolbox we can cover all three. Let's also say to go for the middle and say we make a fins and fan motor. And now we go into the technical data. Let's say we want a motor with 4 Newton meters and 200 RPM. We get an immediate feedback that it is possible to make a motor like this. Here we get a graphical feedback of the size it will get. Yeah, I have to add the scales here on the canvas, but that's basically, we will add numbers so you get a feeling how big that motor is. And now if you want to adapt it, if you go for example to 100 watts, we see the size is a little bit bigger than for the 83 I had, and it also adapted the torque over here. It always adapts the first value you entered, so it keeps the last two you have entered. That's basically a choice I made. Maybe we have to change it later on, but it's interactive. It always gives you a feeling where are you from your values. And then a very important question, can we use a gearbox or not? If we use a gearbox, everything gets smaller, because electric motors like to turn at high RPM with low torque. A gearbox helps us to turn these high RPM low torque into low RPM with high torque. So if I select that I want a gearbox, you get the choice of what kind of gearbox. Let's take the planetary, and we directly see that planetary gearbox added here in our interactive graphics. And we see the motor is much smaller with the gearbox than without. Let's take the gearbox out, so that's the size. It's about 1 square high, and if we add the gearbox, this one, we see it's much smaller. We have the size of the gearbox, but the overall motor size gets much smaller. And here again, interactively you can choose 66 if 66 is a diameter that's too big to fit into your application, you go to 50, and I automatically recalculate how long that motor needs to be to fit into your assembly. Of course we can do the opposite. We can say, oh, we have plenty of space and diameter, but we need to make it shorter. You go to 100 and it makes you a length of 58. Basically in electric motors the torque is a function of the square of the diameter and is linear to length. So it's not so complicated. I will tell in my next video what are the mathematics behind configurations of electric motors and how I want to make a digital model for it to be able, behind that interface, to make a complete simulation and output the manufacturing data I need. Then you need to mount it somewhere. So if we have a flange on the front, you can choose whether you want 3 holes or up to 6 holes, and you again get an interactive graphic that shows you what's going on, and you can make larger holes, smaller holes. You can change the diameter of the mounting holes, and of course we have to refine this a little bit, but you get directly a feeling of what's going on and how it will fit into your assembly. Then the shaft end is also an important configuration because it's the main interface towards your shaft you want to drive with. So I have here several options for shaft ends. Of course, we will also adapt these to the needs of our customers. Maybe have the option of uploading a design for a special shaft. And if you select the shaft, you get you have selected all data, and you get an overview of your selected options. This is now not yet programmed, but you can imagine that's the summary you get before you order. Now here I just have first, last name and email. If you want to subscribe to our email list, you're very welcome. And next would be then that you can directly order, and you get a confirmation emails, and you get your motor like any other web shop. I think what's very important here is that we give you a price and a delivery date immediately. I was in contact with several motor manufacturers in the past weeks for my day job, and just getting a price and a delivery date is quite difficult in the traditional way that motors are sold. I hope you enjoyed that. If you are buying electric motors, if you're interested in electric motors and you think this interface is incomplete, too complicated, whatever, drop me a line, call me up, whatever. I'm very curious to hear your feedback to that interface. Thank you. It's far from being finished, but it gives you a feeling of how I think you can make the whole sales process for an electric motor online. You can go yourself to configure.tailoredmotor.com to give it a try, to test it, and I'd be very happy to get your feedback. If you think we need more data to calculate an electric motor, or if you think it's already way too complicated, we have to strip it down to make it easier to understand for customers. These are the kinds of inputs I'm looking for, and I'd be very happy to discuss that with you. Thank you and goodbye.